We go through the process of planning, creating an attack, testing that attack, and then automating it so that remediation can occur. Once we've identified the vulnerability, the developers have to go and fix it. And instead of paying the pen tester or taking up the time of the resource who found the vulnerability to consistently manually test it, we have them build it and then automate it so that code can be validated for remediation. So the web attacks that we're going to focus on are sensitive data exposure, cross-site scripting, and Sql injection. The environment in particular, we use the Juice Shop, also from a vulnerable web application, and RailsGoat. So these are known vulnerable applications. We're not attacking anyone's website in particular. We have Kali Linux in our environment, Splunk, and Jira to show not just the web application security integration, but how the SIM is integrated and how from the SIM, when that alert is created, that we will generate an issue in Jira so that it's automatically added to the workflow. Okay, with that, I'm going to hand it over to Mark Anthony.
Before we get into the first web attack demo, I just want to talk a little bit about the environment we have here. We have a Juice Shop web application running where we have a Citrix ADC firewall setup that's load balancing on there. So we have one virtual IP that is not protected by the firewall, and then we have another one that is, and we have the same setup for the RailsGoat application as well. So there's a protected and an unprotected route, and we're going to deal a little bit with the differences between those. We also mentioned that we have Jenkins, which we have some attack jobs set up that we're going to go into, and we have a Jira project where we're going to create some issues. We have some Splunk. We're going to go into a dashboard and some alerts, but let's go ahead and just start with the attacks. So we're going to head over to Juice Shop for the first attack, and we're going to do some Sql injection. It's going to start out simple, but we're going to go from there and work towards more complex attacks. So just from the main page of the application, we're going to go to the login page. Now, we know that this login form is vulnerable to Sql injection. So I'm going to just copy this Sql injection string. It's extremely simple. They don't try to protect against this at all on Juice Shop. So what this is going to do is it's going to just select the admin user from the database, and then it's going to escape the rest of the query. So it's not going to do any kind of validation on the password or anything. So I've just entered a random password, and it's going to just let me right in. And as we can see here, we're logged in as admin. So we can also verify that we're logged in as admin and we have administrative access. If we just go to the administration route of the app, and we've reached this place, so we know that we have admin access, we'd be able to do whatever malicious activity we want. But what we're going to do is, now that we know that the site is vulnerable to Sql injection, we're going to jump off of that attack and use more Sql injection to prepare for a broken authentication attack. So we're going to return to the root of the application, and I'm going to show you this Sql injection string right here. And we're going to attempt to do this on the search field of the site. And I know that this is vulnerable to Sql injection, but they're not rendering the results properly because we're unioning on this query and we're getting results in kind of an unexpected format. So coming from the front end of the site, we're not going to be able to see anything useful. So, but what we can do is we can head to the back end, just go straight through the REST product search endpoint of the API, and we can pass it that same query. And what it's going to do is it's going to just give us the raw JSON output of this. And normally this is the product search API endpoint. So if we scroll down here to before the results from our union, we're just getting like the basic juice items from the products that are on the shop. So what we're doing is we're unioning on that query, and we're grabbing from the users table. We're trying to dump the ID, the email, the password, the one-time password secret. So you could discover this just by trial and error, or you could have some kind of SQL map application that does this for you and discovers what the tables are called and the different columns on the tables. But the users table was just called users, so it would have been pretty easy to figure out at least users, email, password are pretty standard names, ID. So we can see that it's dumping the ID of each user here in the name field, and it's also dumping the email. And then this is what would be the password, but it's in some kind of hash form. And what we're looking for is this user here, worst brought, has, if you remember, we're dumping the one-time password secret here. And he's a user who we know has two-factor authentication set up. So if we wanted to SQL inject and try to log into his account, we would still not be able to get in because the two-factor authentication would stop us without the proper authentication code. But since we have the secret here from doing this SQL injection, we can now use this to jump to the broken authentication attack. So I have a Kali Linux terminal open over here, and we're going to just ignore these parts over here for now. And we're going to be dealing with this quadrant over here where I have the Python Authenticator set up. So we don't have to worry about setting up the environment. But what we're going to do is we're going to make sure that I don't already have an Authenticator profile set up for this user, so we can start from scratch. So I'm going to delete the profile I have already. Now we know that it's not there, and we're going to go through the process of adding it. So this Python Authenticator basically works the same way that a Google Authenticator or Microsoft Authenticator works. And we just need to provide a shared secret, which is what we grabbed off this page here. And now it's set up for our account, so we can just say Authenticator generate my password, and it's going to start generating these authentication codes that expire after a short amount of time. But if we head back to the login page, and first we have to log out, log in, and we want to log into that worst brought user. So we're going to do the same thing we did for admin, but we're going to specify worst brought as the email. And then we can enter whatever random password string we want because we are bypassing the password authentication there. And so now it's going to ask for our two-factor authentication code. Luckily, we already have that ready over here. And if I'm fast enough, maybe be able to use this one. Yep. So we now got in to the worst brought user. We bypassed the two-factor authentication, and we would be able to do whatever we want with their account if they have payment options set up or anything from there. So that's the danger. That's one of the dangers of a SQL injection attack. I mean, way worse things can happen from that. But we're going to go and talk about cross-site scripting now. So back on the application root, we're going to try executing just a very basic cross-site scripting attack in this search field that we used before. So we paste this in, and what it does is it creates an iframe with a JavaScript source that just executes a simple alert. And now that we know that it was able to execute arbitrary JavaScript, we're going to see if there's some kind of policy preventing us from making a cross-origin connection. So I'm going to copy this one, which is a little bit more complicated. What it does is it goes out to SoundCloud and pulls a widget to be able to play a song from there, the Juice Shop jingle. And basically, since this worked, we know that we were able to connect to an external site. There's nothing in the, no kind of rule in the firewall preventing that. And so now we're going to use what we know is possible, and we're going to do a more complex attack using that. So we're going to be back on the login page. If I can log out, log in. And I have an account that I use for testing, so we're going to log into that. And I'm using this account because I know I have a credit card set up on there. Not any kind of real credit card data, but just for testing. We have a fake number here. You can see that from the front end, it's actually obfuscated or masked. You can't see the entire number. And this is just a fake name and some date. But so this is our credit card info that we can access from logging into our account. Now, this is going to simulate following a link that might have been given by some malicious actor. We could have received this in a phishing email or even linked somewhere by a friend or something like that. And what this does is it uses that same search field that we use to execute just a regular JavaScript alert. But instead of something simple like that, we're giving it functions and a couple lines of JavaScript code that basically they go to the part in the HTML that has the username, and they grab the username and send it to the malicious server, and it also grabs the document.cookie. So if we execute this, we can see it happening. We have this text box that opens up, and this is just for debugging purposes that I'm showing this. If you really didn't want someone to know that you just stole their information, you could hide this. But basically, this gives us the response of what the server sent back when it received the request. So it received my username, and it also received my cookie. So if we go back over here to the Kali box, we can see that if I just, let me clear this again just so we don't have this character right there. But so we received this request over here. These are the Flask logs from the malicious server. So we can see that we got the request with the username and the cookie, and we logged it to this cookies.log file. So anybody who clicks these links that I send them, they will log their emails and cookies here so I can have a nice list of them. And what we're going to do is we're going to go over to Kali, and we're going to open the OWASP Zap manual request editor, just so I have a nice place to put my request. And we're going to, I have a already ready to go request here. And if I paste this in, it has a few placeholders for where you would give the token and where you would give the email. And this is going to make a request to the backend API cards endpoint, which would give us our credit card details. And what we're going to do is we're going to hijack the session of this user who we just got their email and cookie, and we're going to hopefully get their credit card info. Let me show you that it doesn't work if you don't provide the right details. So if we just give the empty request without specifying a cookie and a user, then we're not going to get any details because you have to provide a valid request for it to work. So we're going to paste that token, paste it there, and then we're going to, oh, shoot. Sorry, I'm messing up here. We're going to paste the token, paste this here, and then the email. So we're going to send that request off, and we got a response that says success, and it's giving me the details from the credit card that we just got. So that's the name that we saw on the page. And this is actually the full number. So it's not being masked in any way. We couldn't see it from the front end, but going through the API, we were able to get the entire thing. So obviously that would be extremely bad for your users. So we could go on and on with the manual testing, but I just wanted to kind of highlight how much effort goes into doing these tests. And you saw how easy it is to make a little mistake, and maybe the test could have given a false result. So what you want to do is automate these tests. So we have these same tests that I've just done. We have them written out in Jenkins jobs. So these Jenkins jobs run Python scripts. They use Selenium testing framework for opening a Firefox browser and going through these same instructions that I've done, but instead of manually, it's automatically. So we're going to look at, first thing we're going to do is look behind the scenes at one of those scripts. And so if I just pull up this terminal I have here, if we look at this cross-site scripting job that I have here. So this is a Python script that runs Selenium. You don't have to worry about some of the setup, but this is going to make a connection to our RailsGoat application, and it's going to basically it's going to set up a new user and do some cross-site scripting on there, which we're going to see in a minute. But basically, we're going to not have this run headlessly so that we can actually see what's happening. So if I just uncomment that, and then I run this on our unprotected RailsGoat app, you'll be able to see exactly what's happening. So it generates a random email and password that it's going to register with. It goes to the sign-up page, and it enters this cross-site scripting script in the first name field. Basically, because we know that when that first name is displayed, it's going to run the JavaScript. So we can see that the attack worked there. If I want to just show you that attack manually real quick, we can head over to RailsGoat. We can sign up a new user. We can say demo123@gmail.com. And in the first name field, we're going to just do something like hello. So that script is going to execute. And we're just going to say it's a cross-site scripting test. Let me set up a password. And so this is what I'm talking about. This page, whenever you log in, it displays welcome and then puts the first name in there. But since we've snuck this cross-site script into the database, whenever we launch onto this page and it displays our name, it's actually going to run the JavaScript. So even if we go here, we can go and edit our profile, and we can change the script to do whatever we want. And someone else who views our profile in the application would then execute our JavaScript when they view our profile. So that's what's happening when we run the Selenium job here, but it's happening automatically. And we're able to do this headlessly, so we don't even have to open a browser window. We can just, if I just cancel the job, we can go in here and uncomment this, and then we're able to run it from Jenkins. So if I head back to Jenkins, and we go to the RailsGoat side, where we have that cross-site scripting attack, we can run the protected job. It's the same job that runs, but against two different virtual IPs, as I pointed out before. So this one should not be successful because we're running against the protected host. So when that finishes in a second. So we see it was a failure because we don't want the attack to be successful when we're attacking our protected host. And then the unprotected one is the same thing. We can run it and it should be successful because there's no protections in place to prevent that. So we're going to move on from here, and we're going to look at some of what I have going on Splunk, where I've just set up a basic dashboard here. Let me get the newest results, where we can see what kind of HTTP requests we're getting from hosts. We can see sensitive data exposure attacks on certain packages that we may not want anybody to have access to. And we can see Sql injection attempts. So if I go and I launch a Sql injection attack on Juice Shop from here. So we're going to run this on the protected Sql injection. We're going to run that. And this, I have set up an alert. If we look at the details of this alert, I just made a Splunk app that lets me specify my Jira details. So I have my Jira URL, my service account details here, my project key for Jira for where I want to create this ticket, and then just some kind of summary that I want put in the ticket. And so that alert should have triggered, which if we refresh here, 1807. So yes, that was this minute. And if we head over to Jira, we should see that we got a Sql injection attack. So we're able to get notifications on Jira so that someone can at least acknowledge these and put in some kind of protection, or you could even have it automatically blacklist any IPs that are attacking you.